Yeah.
Okay, today we're finding critical points, relative extrema, intervals of concavity, and points of inflection of a function. And we're doing all this without the graph of prime. We're going to do it all just from the function. So we've got 4 examples that we're going to run through. And it may take a little while. Because it's going to take a little while, and I'm going to give you an assignment today. We'll work on it tomorrow.
Oh, yeah.
But you need to stay hooked up with me. So our first function is f of x equals 4x cubed minus x to the 4th. And we want to find everything that's in our learning goal for today. Critical points, relative extrema, intervals of concavity, and POIs of the function. That's the law. So, critical points are the first thing. Somebody remind us, raise your hand and remind us when critical points happen. Touch the x-axis. I'm glad you guys can follow directions.
Oh, raise your hand.
Just a second. Alright, so we've got to do it without a graph. I don't have a graph. So you got to be able to describe it differently than that.
Get the derivative.
No.
Where the derivative equals 0, or Harrison?
Whenever x equals 0.
Right?
Whenever the derivative is undefined.
Very good. So, critical points happen when the derivative is equal to 0 or the derivative is undefined. So, Pauline, what do I need to do to f of x equals 4x cubed minus x to the 4th to figure out when that happens?
Find the derivative.
Find the derivative. Very good. Find the derivative. So that is 12x squared minus 4x to the 3rd. Very nice. Ready? What do I want to do next?
Set it equal to 0.
Set it equal to 0. What will that tell me when I do that?
Where
It's
critical
0.
What's critical points?
Where the derivative equals 0.
Very good. That's what it tells me. It tells me when the derivative equals 0 when I set the derivative equals 0.
Not when x equals 0? Yes, when x equals 0.
I don't understand what you're saying with x equals 0. I don't think
It's
you
just-
mean what you're trying to
It's a
saying.
different way of thinking. It's X's way. Just let him do it.
Alright, so now that I set it equal to 0, then what do I want to do? Alex?
Sounds right.
And how am I going to do that?
Right.
It's like saying Jesus in Bible class.
I don't even know.
It's always the right answer.
I'll do
Not
okay,
sure.
it's true. Okay.
Not sure how it's different.
Factor.
Factor. How am I going to factor?
With a slide.
Oh, I do that with trinomials. I don't know trinomial.
True.
Number one rule in factor.
Oh, take out.
Take out. What am I going to take out?
What's the number 2 rule in
Take out.
factor?
There is not a number 2 rule
Or
in factor.
explain.
There's only one rule.
The one rule.
There's just the one rule.
So that gives me 3 minus x when I take out the 4x squared. Chelsea, what do I do next?
You set 4x squared equals 0 and 3 minus x.
Very good. So this first one's going to give me x equals 0. 3 minus x equals 0 is going to give me x equals 3. Anyone just fine?
What is the other equals 0?
So what does that tell me I just found? Critical points. Good. So I found the critical points. Now I'm interested in relative extrema. Erica, what has to happen if I'm going to get relative extrema?
Needs to go from positive, negative, and negative.
What does?
What does?
F from it.
That's prime of x. You're correct. Thank you. That's right. Alright, and Erica, how am I gonna find that out? What am I gonna do? I'm gonna do yes, we're gonna call it a sign line. Last year they called it a sign line, I liked it. Because we've got a number line and I'm interested in the signs of it. So the easiest thing to plug in is 1. Whenever you can plug in 1 or 0, that's the best thing you want to plug in. So I'm going to plug in 1. If I plug in 1, this right here is positive. This right here is positive, so the combination of the two are positive. So that means that section right there is positive. So, Kaylee, what's the section on the right of 3 going to be? Positive or negative and why? You're thinking too much.
Negative.
Negative, why?
There's no multiplicity.
There's no multiplicity on 3. What about 0? 50-50.
Negative.
Positive.
Yes.
Rock, why is it positive?
Because there's a multiplicity on.
Because there's a multiplicity where 0 came from. 0 came from this right here. There's the multiplicity on 0, so that means signs will not change. 3 came from x minus 3. There's no multiplicity there, so that means signs will change. Okay? So now, Brock, I should be able to tell whether or not I have any relative extrema. So give me the relative extrema and justify it for me.
Relative maximum of 3 because f prime of x changes from positive to negative.
Outstanding. Very nice. So I have a relative maximum at x equals 3 because f prime of x changes from positive to negative. Perfect. So we've done critical points, we've done relative extrema, now I'm interested in concavity and points of inflection. So, Harrison, what am I going to do to find those? Doesn't matter, you said you knew it already.
You said
Okay.
you've already got it.
Whenever the slope changes from negative to positive, or positive to negative.
Alex, what do you think? Who can help me out here?
Is it the second derivative?
I need the second derivative. So that gives me 24x minus 12x squared. Then what do I want to do?
Do it back to this.
And do what else with it?
Solve.
How am I going to solve?
Say equals 0.
There we go. So set it equal to 0, take out a 12x.
That's
That gives me 2 minus x. So that means we're going to get x equals 0, and we're going to get x equals 2. So what might x equals 0 and x equals 2 be?
Point of,
They might be points of inflection, but I do not know yet. Why do I not know? I haven't done the sign line yet. What's the sign line going to tell me, Brock?
If it changes from increasing to decreasing, that prime of x.
You're not saying it right. What's the sign line going to tell me?
is positive or negative.
Whether or not it changes signs. Because remember, what does the second derivative have to do to have a point of inflection? Change signs. So I've got to see if I'm going to change signs. And I can actually tell it without a number line. How do I already know my signs are going to change?
There's no multiplicity.
There's no multiplicity. Very good, Rob. Okay, but let's go ahead and make it look good and find the signs because we're going to look at it graphically here in a second. So again, we want to plug in 1. If I plug in 1 here and here, what do I end up with? Positives. So that means those outsides are negatives because I don't have any multiplicities. So we do see now that 0 and 2 are both points of inflection because f double prime of x, let's change the sign. Okay? So that's what you want to write down. Well, first of all, let's do intervals of concavity. I forgot about that, so that's why we need. I'll get there. So I need intervals of concavity. So what's going on from negative infinity to 0 and to infinity? What do I have there? Concave up, concave down, and what?
Concave down.
Down, why?
Negative.
Because f double prime is negative. And then from 0 to 2, we are concave up because f double prime is positive. And then we say our stamped answer for a POI. What's our stamp answer for a POI? Can't use that because I don't have the graph of f prime of x. I'm dealing with f double prime. What is f double prime?
Double prime changes from.
There we go, because f double prime changes signs. So let's That's what I'm looking for. So let's look at all this on the graph. Yes.
On the worksheet before, we had to justify for one that was increasing and decreasing, one from decreasing and increasing. You don't have to separate when you're doing that.
We'll talk about that here in a second. But yes, you are correct. All right, so notice I've got everything written that we just found over here. We've got a relative maximum at x equals 3. And we didn't talk about this, but how do I know I'm increasing from negative infinity to 3?
Positive.
What's positive?
F prime of x.
F prime of x is positive, so that tells me I'm increasing. Then I'm decreasing from 3 to infinity because f prime of x is negative. We've got concave down here, we've got concave up here, and we've got points of inflection at 0 and 2. So let's look at the graph and verify all that. So here's the graph of this function. So let's start with my maximum. Does it look like I have a maximum at 3?
Yep.
Yes. Does anybody remember the keystrokes to find the maximum from pre-calc? You do? What is this? What is it?
Oh, I don't know how to do it on this one. I know.
Menu.
Starter.
Analyze graph.
Analyze graph.
Yeah, that's what
Maximum.
Maximum on the left, on the right, there's our maximum
Ooh.
at 3. Just like we said it would be. Okay, do you agree? Do you agree from negative infinity to 3 that that graph is increasing?
Yep.
Yes. Do you agree from 3 to infinity it's decreasing?
Yes.
Yes. Do you agree from negative infinity to 0 and 2 to infinity I'm concave down? So negative infinity to 0, do you agree that that's concave down?
Yes.
Yes. And then from 3 to infinity, you agree that's, well, what did we say that was? 2? Yeah. 2 from here around, concave down. Okay? And then in between those, 0 and 2, between 0 and 2, I've got a point or a concave up there. So my point of inflection is here. It's pretty obvious to see it there. But it blends in pretty good here. It's tough to see it at 2. Yes.
You don't have to do negative infinity to 0 and 0 to 2
On
or
what?
0 to 3 on increasing or
No, because it's increasing. It's increasing the whole time. It's not going to change. Okay, so what have we been looking at though to figure all this out? What have we been doing the last 2 days?
analyzing a graph.
Graph of what?
F prime.
F prime. So let's look at F prime of this thing and see what it would look like.
So wait, does this give you goosebumps since we're taking a graph out of
It's
it?
good stuff. All right, so this is the graph of F prime. This is the graph of F prime. All right. Notice. All right. Notice. What should F prime be doing at 0 and 3?
stop.
Decreasing. Decreasing.
What are 0 and 3? They're critical points. So what should they be doing? They should be touching the x-axis. So here's my derivative. Am I touching at 0 and 3?
Yes.
Yes. Okay. What do these two positives tell me? It's above the x-axis, and this one tells me it's below the x-axis. So notice, both sides of 0, I'm above, and then when I get on the right side of 3, I'm below, just like we said. Okay? Then, here's where we pull in what Pauline was talking about. Okay? What needs to be happening at 0? What do I have at 0? Right. What did you say, Pauline?
It changes from decreasing to increasing.
My F prime needs to be changing from decreasing to increasing. Am I doing that?
I thought it was
Yes.
double prime.
F double prime changes sign. We're looking at F prime. If we're talking about F prime, it changes from increasing, decreasing, and vice versa. Okay. So what needs to be happening at 2? It needs to change from increasing to decreasing at 2. So 2 is way up here, and you can see that it changes from increasing to decreasing. So all of that was verified. Alex.
Okay, I just got a little confused.
That's fine. That's confusing.
We said something about we use F prime for, I don't even, never mind, I don't even,
No, that's a great point, and we'll go back to what Pauline talked about. When we have a graph of f prime, we use f prime to talk about points of inflection. What is our justification if I have f prime?
Increasing or decreasing.
Changes from increasing to decreasing or decreasing to increasing. But I can only use f prime to talk about a point of inflection if I have the graph of f prime. If I do not have the graph of f prime, what do I have to use for points of inflection? I have to use the second derivative.
Double.
And what does the second derivative need to do?
Change signs.
Okay.
The second derivative needs to change signs. So if you have graph of f prime, then you're going to use f prime by saying increasing, decreasing, or vice versa. If you don't have a graph, you've got to use the second derivative and say change the sign. Okay. Next one.
Is there ever going to be a convex?
No. We just deal with concavity.
Yeah.
All right, these next two problems, the second derivative is nasty, so we're not going to worry about the second derivative. We're just going to worry about the critical points and relative extrema. So I have f of x equals 4 divided by x squared plus 4. F of x equals 4 divided by x squared plus 4. I'm interested in critical points and relative extrema. Janine, what do I do to get started? Find the derivative. What's something I want to do to this before I find the derivative?
Take the 4.
Can't let force.
Divide by 4.
You
Or
can't
split it up.
Don't
You
take
can
four.
move it to the side.
You want to,
I want to move to the top.
yeah.
Move to the top.
I know you want to do that.
Why do I want to move to the top?
Because there's just a number.
Because there's no variable, there's just a number in the numerator. So now I take the derivative of that. So I bring the negative 1 down, gives me negative 4. Inside stays the same. I subtract 1, gives me negative 2. Take the derivative of the inside, gives me 2x. If I don't want to move it to the top, what else can I do? I can do the quotient rule, you get the same answer. Whatever floats your boat. So that gives me negative 8x over x squared plus 4 squared as my derivative. Now, this problem is different than the first problem. Why is this one different?
Fraction.
Because I'm dealing with a rational function. Okay? When I'm dealing with a rational function, there's something else I need to consider besides just setting it equal to 0. What makes the bottom 0 is going to make my derivative what? Undefined. So at this point, I'm going to set it equal to 0. But then I'm going to take each piece and set it equal to 0. When I set the top equal to 0, what's that going to give me?
0.
When it equals 0, when I set the bottom equal to 0, that's going to give me
When it's
when
undefined.
it's undefined. Good. So when I set the top equal to 0, that's just going to give me x equals 0. On the bottom, get rid of the square. X squared plus 4 equals 0. I get x squared equals negative 4, and we should realize that we're running into a problem. What's my problem?
You can't.
A square cannot be a negative. So that means x equals 0 is my only
CP.
point of inflection, or critical point, yes. So after I find my critical point, what do I do next? Pauline?
Question.
Yes.
Did we solve for the one on top? The negative 8x over x squared plus 4 squared? Do we solve that whole thing?
We set this equal to 0, and then we set the top equal to 0, and we set the bottom equal to 0.
If that would have worked out, would we just combine them?
What do you mean combine?
Like, if the bottom worked out, say it came out 4,
Yes,
will we put it 0 over 4?
they're separate.
Comma 4.
All right, Brady, what's next?
Number one.
Number line, sign line. And the only thing on my sign line is
0.
0.
I think we're doing trick. It's tricky. It's tricky.
Are my signs going to change?
Yes.
Yes, because it wasn't a multiplicity, so I just need to plug 1 in, figure out what 1 is, and then I know both of them. So let's plug 1 into the top. What do I get? Negative. Plug 1 into the bottom. positive, so that's going to give me a negative, which means that side has to be positive.
When you say there's no multiplicity,
Yes. That means this right here. If it was x squared, then that would be a multiplicity. Since it was just 8x, there's no multiplicity, and my signs are going to change.
so if there's x.
If you've got x squared by itself, or if you have something in parentheses squared, like this right here, if this would have worked out to some numbers, whatever I'd have found would have been a multiplicity, because it occurred twice. And that means whatever I'd have found, my signs wouldn't have changed. And you'll see that on the next problem, because that happens on the next problem.
Spoiler alert.
So, Alex, what do I have at 0, if anything? It is a critical point. What else is it? What type? And why?
Why is a giant wall right here?
Relative max. So I have a relative max at x equals 0 because my stamp answer is f prime of x changes from positive to negative. So write that down. I have a relative maximum at x equals 0 because f prime of x changes from positive to negative. So let's look at this graph. What should be happening on the left side of 0? Increasing. On the right side, decreasing, and 0 should be my maximum. So let's look at it. There it is. Am I increasing on the left?
Sure.
Yes. Decreasing on the right?
Yeah.
Yes. And my maximum is at 0.
Okay.
So we've got that. We nailed it.
Are we gonna do x f? Can we see f prime?
Can we see f prime? Alright, here's f prime. Let's see if that matches. This tells me f prime should be what? The positive tells me
Positive.
above the x-axis, and the negative tells me below. So I've got above on the left, below on the right, just like we said. All right, next one.
I like it's easy, dude. Stuff's easy. No.
So can we just comment on that graph?
Okay, this is another one where the second derivative is kind of nasty, so we're just going to worry about critical points and relative extrema. So, what do I want to do to start? Quotient rule to find the derivative. Why do I need quotient rule on this one? Variable on the top, good. So I have bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Now, there's something going on in the numerator of this problem that we need to notice, and we need to be able to do something with it every time to make life easier. What do we notice in the numerator?
2x minus 2x.
There's two x's on both sides. I have a 2x on the left and a 2x on the right. When I have something like that, what do we want to do? Factor it out. That makes life much easier. So that leaves me with x squared minus 9. Make sure you distribute the negative there. Negative x squared minus 1.
No, those would just cancel.
So these cancel. And I end up with what in here? What do I end up with there? Negative 10 times this 2. I get a negative 20 x on the top, and I get x squared minus 9 squared on the bottom. Okay, Justice, what's next? Set it equal to 0. Okay, and then what am I going to do?
Just do the
Set the top equal to 0 and the bottom equal to 0. But notice, I always set it equal to 0 first, because the people grading your paper are going to want to see that you're setting the derivative equal to 0. So set it equal to 0 before you separate it and set them separately equal to 0. They're going to want to see that. So 0 equals negative 20x, which gives me x equals 0, and then the other one, x squared minus 9 squared equals 0. I need to solve that, so I get rid of the square. I add the 9 over, and I get x equals plus or minus 3.
Multiplicity.
They are multiplicities, so what's going to happen? I'm going to have the same signs on both sides of 3 and both sides of negative 3. Now, whenever you get a critical point from the denominator, you have to check something.
At least 0.
You have to make sure, you have to see what it does to the original equation. Okay? So I need to see what 3 and negative 3 do to the original equation in the denominator. What does it do to me?
Makes it 0.
Makes the denominator 0. If you get a critical point from the denominator of the derivative, and it also makes the original function 0 in the denominator, it is not a critical point. These are not critical points. 3 and negative 3 aren't actually critical points because it makes my denominator of the original function 0.
Doesn't that make it undefined and make it?
It makes it undefined in the original function, yes. So what do I have there if I'm undefined in the original function? I've got a hole, but in this case I've got a asymptote. I've got asymptotes. But they still need to show up on your sign line. Because your signs can still change at asymptotes. In this case, they don't change, but sometimes they'll change at the asymptotes, so they still need to show up on your sign line. But you've just got to make sure that you know those are asymptotes and they cannot be relative extreme. All right, so easiest number to plug in? 1. So I plug 1 in the numerator. Negative. My denominator is always going to be positive, so a negative over positive means this section is negative. I know those two alternate. Why? 0 is not a multiplicity, but I know the other ones are going to be the same. So this has to be positive, and that has to be negative. How do I know that? They are multiplicities because of this square right here. Pauline?
What if we did the 3's first to decide sign, and you said multiplicity, so both sides would be the same sign? Wouldn't that make the whole graph?
Nope. If I did the 3 first, it's still going to work exactly the same. I'm glad you asked that though. So for instance, let's say I did the 3 first and I got a positive there. Okay? I know that this also has to be a positive. But since 0 is not a multiplicity, I know that 0 has to change. And then I know that this one has to be the same because it is a multiplicity.
Should we go left to right?
It doesn't make a difference. Once you figure out what 1 is, then you know whether or not it's going to change or whether or not it has to stay the same.
So should you just not do the ones without multiplicity first to be safe?
If you feel more comfortable that way, then yes. But it shouldn't make a difference. Because you should know at negative 3, I'm going to have the same signs. At 0, I'm going to have different signs. So if I'm positive here, that means I've got to be negative here. And at 3, I should know I'm going to have the same sign. So if I'm negative here, I've got to be negative there. So it really doesn't make a difference, but if you're more comfortable one way than the other, that's fine. So, do I have any relative extremes you need?
Yes.
Where?
At 0,
What is it?
the max,
Because?
probably back to the change from increasing, decreasing.
Close.
From positive to negative.
Positive and negative, that's my standard answer. Relative max, the only answer is, the only justification is, because f prime of x changes from positive to negative. That's the only thing. So, we said at negative 3 and 3, I've got asymptotes. What should my graph be doing on both sides of negative 3? Increasing. So I should be increasing on here, increasing there. At 0, I should have my, what Janine say it was? I've got my max at 0, and then both sides of this asymptote, I should be doing what? I should be decreasing.
We'll look at the graph.
So, This is what the graph looks like. Should be pretty obvious that I've got asymptotes at -3 and 3. What did we say was going on both sides of -3? Increasing. I'm going up here. I'm going up there. So I am increasing. We said at 0 I had my max at 0. Then we said we were decreasing and decreasing just like that. Okay? Let's see what the derivative looks like. What should happen to the derivative? What's going on the left side of 0? What's going on the left side of 0?
Decreasing. Increase.
No.
Above.
Decreasing.
It's above. If we're talking about the derivative, it's above. So this tells me I'm above. Over here I am below. What should be happening at -3 and 3?
Asymptotes both going up or down.
Right, I should still have some type of, I should still be undefined in some way or another. Okay? So, positive on both sides like we said. The asymptote is still there. What happened at 0? Critical point. And it's a relative max because change from positive to negative. I've got my other asymptote, and we said we were below the x-axis on the derivative as well. So
Did we find critical
we
points?
nailed it all.
What's the login and Shane for senior tech tour class?
Does it have to be right now? Because we're in the middle of some good stuff.
I thought we were at
Like,
the
as
end.
soon as y'all are
You said we
done.
had 3.
Thank you.
Where am I sending them?
You're right.
All right, last one.
Did we find points of inflection?
Okay, so points of inflection.
Did we find it with the numbers?
Say it again.
Did we find points of inflection with the numbers on that one?
We didn't find points of inflection because we said the second derivative was too nasty.
Oh, it's nasty. Oh, that's nasty.
And
Why do you pick problems that will end up being nasty?
I don't. But you're gonna have both. You're gonna have some where they're just gonna worry about the first derivative, and some where you can get to the second derivative. You
Are
need
they
to be able to
gonna
do both.
tell us?
But they're not gonna make you do the ones I don't want to do the second derivative on. They're not gonna make you do the second derivative either. They won't give you anything that gets nasty. All right. So this is my actual function. Even though we didn't get the second derivative, we should still be able to tell whether or not there are any points of inflection. Are there any points of inflection?
0.
0 is not a point of inflection. What am I looking for?
Positive, negative.
No, we're looking at the actual function.
Vertical tangent.
No, we're looking at the actual function.
Horizontal.
Like the numbers?
So we are looking at concavity. What is my concavity right here?
Going up.
Up. What is my concavity in the middle? Down. What's my concavity over here? Up. So the only points of inflection would have to be at -3 and 3, but they're not points of inflection because there's nothing there.
I don't think that couple
There's an asymptote.
The things on the left and right are concave up.
Yes, concave.
Concave up.
Cup.
Concave up.
Cup.
Concave down.
Like a flag.
Even if one of them's decreasing.
It doesn't matter if it's decreasing. It just matters where the shape's going. Is the shape going up or is the shape going down? All right, we need to move
The
on.
ship's going down.
It's
What?
It's shaped like a cup.
Okay.
Put your hand just like that. Is it going up or am I going down?
I don't know.
Oh, is this going up? This is going up. Right here, what's it doing? It's going down. So that's how you tell if it's
It's
concave or
going
concave
down on the left though, on that
Okay.
part.
It doesn't matter where it's going. It matters
Misunderstanding.
what the curve is doing. What the whole curve is doing. Is the whole curve facing up or is the whole curve facing down?
Oh.
It doesn't matter if I'm increasing or decreasing. It just matters what the curve is doing.
That applies only to the original function.
That applies only to the original function. That's what's tough about this is you got to be able to differentiate what is it that I need to be looking for with the graph I'm looking at. Because then when I go to the second derivative, my mind should change. I'm no longer looking at the actual concavity, I'm looking for increasing and decreasing. Okay? What am I doing? What am I doing here?
Concave up.
I'm increasing, which means I'm concave up. In here, I am decreasing, which means I'm concave down, and I'm increasing, which means I'm concave up. So you've got to be able to differentiate between what you're looking at. All right, we've got to get one more problem in without Harrison interrupting me.
Why
Coming
do you
up with
around
this
like
crazy
that?
question.
I didn't understand.
Well, you've been here yesterday, or watched the video.
Is there a video? There's not a video of this one though, is there? Because you're making a video.
I've got one already.
But this
I
is
used
gonna
previous
be
years.
this is gonna be the new one.
It was going to be the new. Dang it.
You don't like our answers?
Alright, so on this one we're going to find everything. I want critical points, I want relative extrema, I want concavity, and I want points of inflection. So Brock, what do we do to get started?
Find the derivative.
Find the derivative. What's the derivative of negative cosine? Sine. And the derivative of negative 1/2 x? 1/2. So there's my derivative. Erica, what do I do with my derivative? Set it equal to 0.
That's not inside the cosine?
This right here?
Yeah.
No, it'd have parentheses if it was.
Okay.
So sine of x 0 equals sine of x minus 1/2. Chelsea, now what? You gotta channel your pre-calc then. Kaylee? So I add the 1/2 over, and then I ask myself when does sine equal 1/2? Where?
30.
At 30, what is 30?
Pi over 6.
Pi over 6. In calc, we use radians. So it's going to be pi over 6. But there's another place where sine is a positive 1/2.
5 pi over 6.
5 pi over 6. How'd we come up with that, Brady?
I'm a good guess.
At a third degree?
One less
Under
than
it,
it's
the second quadrant.
the second one.
Sine positive in quadrant 1 and quadrant 2, and to put something in quadrant 2, what was the trick?
1 less than
1 less than the denominator. So that's how we end up with 5 pi over 6.
I'm learning so much.
So on
Alright.
trigs we'll have more than one.
Say it again.
On trigs we could have more than one.
So now what do I want to do?
Those are critical points?
Those are critical points.
Sine.
Sine line. Now I've got pi over 6 and I've got 5 pi over 6, but I actually need to put ends on this one. Why do I put ends on this one?
It's 0 to
0 to
Because they gave me a domain restriction. So I've got to have 0 here and 2 pi there. So now, just like everything else, if a trig function does not have a multiplicity, then my signs are going to change. So all I've got to do is figure out one of these. And I recommend using one of the quadrantals. The quadrantals are good ones to have, because what are my only 3 things that sine or cosine can equal? Add a quadrantal. 0, 1, or negative 1, and those are easy to handle. So, what is between 0 and 5 pi over 6? Pi over 2. So we want to deal with pi over 2. What is sine of pi over 2? 1, and 1 minus 1/2 is positive. So I know this is positive, which means those two have to be negative. So when you can, use a quadrantal because they're easy numbers. It's got to be 0, 1, or negative 1. So, Logan, what do I have at pi over 6 and 5 pi over 6 and y? What do I have at pi over 6?
A relative minimum.
Because
F of x changes, f prime of x changes from, is it decreasing to increasing, negative to positive,
okay, what do I have at 5 pi over 6?
relative mass?
Because
F prime of x changes from positive to negative.
very good.
Why
Alright.
is this one not increasing to decreasing, like the one yesterday?
Yesterday, what were we dealing with? Points of inflection and concavity. We're doing relative extrema, which would be
It's like Monday.
2 days back.
So
Do that. All right, so there's relative extrema. Now I want concavity. So what do I need to do to get concavity, Justice? And points of inflection. What do I need?
Find the second derivative.
Second derivative, good. So derivative of sine is cosine. Derivative of 1/2 is
Zero.
0. So I'm just dealing with cosine. So, now what?
Take equal to 0, solve for x.
Set it equal to 0.
How's this?
So, Brock, what am I asking myself at this point? Besides, why am I in calculus?
What was I gonna say?
Huh?
That's really what I was gonna say.
I knew it wasn't. What am I asking myself?
What are you asking yourself?
Well, what should you be asking yourself at this point?
I don't know.
Janine, what should we be asking at this point?
What is cosine 0?
When is cosine 0? When does
That's
that happen?
all by myself.
When does that happen?
That happens at 502.
And?
5.
3 pi over 2.
Yeah. That's what I was gonna say.
I hope
I just
so.
wanted to make sure you were paying attention.
Alright, so sine line again. I've got pi over 2. I've got 3 pi over 2. So is there a quadrantal I can use that's not up there?
Pi.
Pi.
This one will still be positive.
So what is cosine of pi? 0, 1, or negative 1?
Negative
It's negative 1, so that means this is negative. Those two are positive. So Erica, what is my function doing between 0 and pi over 2? Nope. Looking at the second room.
Concave up,
Concave up, what's it doing between pi over 2 and 3 pi over 2?
concave down.
And here, concave up. What's going on at pi over 2 and 3 pi over 2?
Okay.
No.
Concave down.
Point of inflection, why?
Changes sign.
What changes sign?
That's
Double problem there.
Oh,